So to begin with, just to check the answers to your work, practice 9. Any problems, questions? Okay, if not, moving on. Now, this is your classmates' answers to practice 10. Wait. Okay, for practice 10, this is the answer of your classmate. Thanks a lot for volunteering. As mentioned, the diagonals are kept because the card is put back, so the same card can be drawn twice. And her outcomes are listed in the table. Something comma something represents that particular outcome, whereas the sum, the first item, the numbers are the same, 4/16. Sum is more than or smaller than 8. So for part B, if you didn't count same as your classmates, I think these are the cases where the sums are not less than 9. So not less than means greater than or equal to. So instead, actually the other way around. But in any case, luckily, those are the same answers. So it's 1/2. And finally, difference equals 4. Difference equals 4 involves these two cases. So 1/8. So far, so good, I guess. So moving on to the question in exercise 5B, the question 10 in exercise 5B, because many of you will ask how to draw this particular question. So one option, like your classmate did here, is to let A be the correct option. If she let A be the correct option, then AA is the only correct answer. With both correct, then it's 1/16. 1 correct 點數啊？AA 係正確答案啊嘛，你當。So how many of them has 1 correct? This one, this one, this one. Anything else? Exactly 1 answer correct means also these. So there should be, yeah, as some of your classmates mentioned, 6 answers which are 1 correct. Question: why can we allow A to be the correct answer? Because it's symmetric, you may mention that. So is there any way, if you find it very hard to explain why A is the correct answer, is there any other ways we can present our answer such that there's no ambiguity as to which is the correct answer? Yeah, okay. Let's say right and wrong, just to avoid the word C. You can call them, one of the answers must be right, the other 3 must be wrong. In this case, because there's only 1 correct option, well, to be fair, C is better 嘅，因為佢 correct 好似有用到。Okay, I'll use C. Okay, and then of the other options, again, correct and wrong are the options, etc., etc. So you will also find counting the number of C is a possible way to answer this question if you present like this. Okay? So if you draw a tree diagram, it should look like this. One more option is a table. You can still draw the first question and the second question. Again, you can claim correct, wrong 1, wrong 2, wrong 3, correct, wrong, other wrong options, and then just list them out. etc., to give your answers. Any questions here? This is another presentation allowed. So you may briefly write that down to give yourself more options. Okay. My question for you then. When do we use a tree diagram? First of all, sometimes we don't even need to use a tree diagram or a table. We just count. When do we use a tree diagram? When there are fewer options is compared with a table, I guess. But how about when do we use a tree diagram in general? Anyway, first of all, of course, when the question asks for it, there's no choice then. But also when 當你要做兩樣嘢，其實同學嘅意思係 when you have to, there's a two-step process. What does that mean? For example, tossing a coin 3 times, then first toss, second toss, third toss. Tossing 3 coins, you need to wheel the first coin, second coin, third coin. In this case, answering 2 questions. So first question, second question, first question, second question, and here is the first question, second question. So in all these cases, there are 2 steps or above. Then you need to use a tree diagram. Okay? But how about a table? To present our outcome. Again, when the question asks for it, then you have no choice. Also, when it is a 2-step process, when you have the first step, you throw a dice 2 times, the first dice, the second dice. Then how do you distinguish between these 2? Grace. So remember yesterday I started with the question, how likely is does the family have 2 boys and 1 girl? You can't use a table unless you can draw a 3D table satisfactorily on a book. I have some students who tried it. It's not that hard, but not recommended. Okay, so exactly 2-step or greater than or equal to 2-step. Then, as Charmaine mentioned, in a table, usually the table is useful when there are many options. Like 2 dices, you probably won't want to draw a tree diagram because the 6 branches are way too tedious. A table is much neater and easier to analyze. Okay? So in general, 5 times 4 or above, I prefer a table. There's no reason why you must draw a table. If I ask you in a 5 times 4 case to draw a tree diagram, please still draw a tree diagram. But in general, this one is we use a table. 4 times 4, similar. As you can see in this question, both the table and the tree diagram have their own merits. Whereas, when you have a 3 by 3 case, you can still draw a table, but in this case, it seems that the tree diagram may be a little bit easier, okay? But it's all up to you, okay? But when you have more than two steps, then you have no choice but to draw a tree diagram, okay? So today, main part is to teach the next few pages of the notes. Page 15. Methods of listing outcomes. So we mainly want to discern between these three cases. The first case is called with replacement. With replacement means that the selected object will be returned before the next object is taken, and it can be the outcome of the next draw. Have you had these cases before with replacement? 有，例如去某著名壽司店抽公仔嘅時候，嗰個波係擺翻落去，即係你抽到嗰張飛仔係擺翻落去噶嘛？你唔知anyway， 有好多抽獎嘅情況，若果係譬如抽1到10號嘅獎咁樣，1號到10號嗰10個獎，咁譬如你上手抽到9號，佢唔會話9號就冇晒啦，9號有無限供應嘅，你都擺翻個9號落去，你再抽噶嘛。So that is with replacement. Okay? So with replacement means that the probability of getting the same item in the next draw is identical. It doesn't affect the probability of the next draw. Without replacement, however, is another case where the selected object will not be returned and cannot be the outcome of the next draw. 例如呢，例如聖誕聯歡會大抽獎，你哋個個都擺晒自己個名入去個袋度，咁抽到你之後就唔會再抽到你㗎啦嘛，應該。Okay? So, or when I select you to answer the questions, I'm using this machine which is without replacement. When I draw a name, in a short while, your name shouldn't appear again until the whole process is started and repeat again. Okay? So this is without replacement. So far, clear, right? So the most important concept or idea here is at the same time. At the same time 即係乜嘢咧？即係有冇可能我連續兩個 draw 都係抽到？唔係，即係我同時抽兩樣嘢。即係你當我聖誕聯歡會要抽快啲啦，所以我一次過抽兩個同學出嚟。咁有冇可能抽到同一個同學㗎？唔會㗎嘛。So at the same time, the key idea is that at the same time is the same as drawing without replacement. The idea is that the outcome is basically the same as drawing without replacement. 明唔明？咁你話唔係喎，真係一齊抽嘅喎，你唔可以話佢係冇抽咗第一個再抽第二個喎。好，我兩個方法俾你去諗呢個一齊抽嘅。第一個方法就係話 ，OK， 你一齊抽兩樣嘢。你中意嘅話，右手抽一個，左手抽一個。咁唔同啦啩？咁跟住我擺低左手，右手嗰個擺低左手個後，咁咪 without replacement 咯，明顯地係。又或者你另外一個諗法，點解一齊抽其實等於分開不過唔擺翻咧？一齊抽另外一個諗法咧就係 OK， 我抽完之後，我將嗰啲排列晒出嚟，即係亂咁排嘅啫。咁但係個排列就係randomly put one object first and then the next object next。咁若果我抽兩個抽兩個波嘅時候，咁樣呢兩個波排出嚟，咁你咪見到 it is essentially the same as without replacement。好，若果有少少唔明嘅唔緊要，我哋做咗啲 with replacement 嘅題目先。Okay, with replacement, there are two red balls, one blue ball and one green ball, so you must let something stand for something, but I will skip that line. You understand what I mean already. Now, I want you to list all the possible outcomes using a tree diagram. So, in the first ball, first draw, whatever, you may end up with the first red ball, the second red ball, the blue ball, or the green ball. For the second ball, what may you get? Can you get R1 again? Highlight with replacement. With replacement means that the R1 is returned to the box. So you may get R1 again. Okay, let me not be so lazy. This part, I think, better actually draw it. So just now, a classmate asked how nice this diagram should be. The thing is, you don't need to draw using rulers, but it should be clear that where the branches go and which outcome each branches lead to. So, for example, I will accept my own diagram on the board here, even though it's not the nicest one on earth. Okay, you may now fill it in, and whenever you're asked to draw a tree diagram, you need to draw the full diagram, even if some parts are irrelevant. Okay? So as you may expect, the number of outcomes is 4 times 4, number of possible outcomes, and the probability 1 red, 1 blue is either you draw the red 1 first or the red 2 first, and then the blue, or you draw the blue first and then the red 1 or the red 2. Those are the 4 cases which leads to 1 red, 1 blue, and the answer is 1/4. So this is with replacement. There's always a chance of drawing the same ball many, many times as well. So for example, blue is a possible outcome. Example 14 is essentially the same question. So what's the difference? They want you to use a table. You still highlight with replacement. With replacement, the key feature of the table is that the diagonal is allowed. So if you draw a table, you will start by red 1, red 2, blue and green. That's the first ball. And the second ball can still be red 1 or red 2 or blue or green. So, for example, the outcome would be R1, 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 R2, etc., etc. So the probability of 1 red, 1 blue, again, you can see there are 4 times 4 outcomes, and 4 of which are favorable. That's example 14. So for completeness sake, let me draw the full diagram for you so that you can refer to it. Any questions? Usually, the question you would like to ask here is that, Mr. Yin, are you required to distinguish the 2 red balls? 可唔可以淨係寫 R 啊咁樣？咁理論上係得嘅 ，unless they want you to be very clear about which red ball. Otherwise, if you skip the 1 and 2, usually accepted in exams because well, you have no obligation to define them as 1, 2. But 1 and 2 1 and 2 helps you to understand exactly what's happening. OK， 咁所以如果你初期做咧，我建議你將 R1、R2分開寫，令到我哋明白啊，原來抽到 R2、R1 即係兩次你抽到唔同波嘅，只不過佢哋 happen to be 紅色啫。Is that right？ 好，有點悶。Let's move on to without replacement. Without replacement 可唔可以用 tree diagram 啊？其實 without replacement 唯一嘅分別係咩啊？Without replacement means you can't draw exactly the same ball. So in this case, if we still start with the first ball being R1, then the second ball can be R2 or B or G, but no longer R1. Because you don't replace it anymore. 即係抽咗就冇㗎啦，嗰個第一個紅波已經冇咗啦咁樣。So can you draw 2 red balls? Yes, because there are 2 red balls in the box, but you won't draw the same red ball twice. And does that have an effect on probability? We will see soon once we fully draw this diagram. But in a table, be very careful which options are allowed. For example, now that we draw a blue ball first, you won't draw another blue ball. So, number of outcomes, how to count. The first ball, 4 options. The second ball, how many? 1 less option, so that's only 3. And you end up with 12 options. And the probability of 1 red, 1 blue would be something over 12. How many cases are there? Let's count. This one, this one, this one, and this one. You still have 4 cases because you can't repeat, but 1 red, 1 blue is not repeating. Still 4 options, but now the probability is higher. You get a 1/3 probability of drawing different balls, different colored balls, 1 red and 1 blue. Okay? Okay, we're going to conclude this part soon. Again, without replacement, and I want a table, what would the key feature of the table be? We have seen it once already. So the first ball can be the first red ball, second red ball, blue ball, green ball. The second ball can also be the first red ball because sometimes you don't draw a red ball first. But if you cannot repeat, then if you cannot draw the same ball, what is prohibited? You will see that the diagonal is prohibited. You can no longer draw the same ball, so please draw this line to indicate that you won't have the cases represented by the diagonal. R1, R1, or B would be banded. and the rest still needs to be filled in. There's still a possibility to draw, for example, R2, R1. So in all these cases, possible outcomes, how to count? 你會點數啊？兩個方法嘅。If you consider each column or each row, there are 4 rows and then number of outcomes on each row. This is basically just 4 times 3. Alternatively, you may count it more intuitively. 4 times 4, the whole table, minus 4, minus the 4 options you removed. So in part B, it's the same thing. The probability of 1 red, 1 blue is, out of the 12 cases, 4 are favorable, so 1/3. So please work on practice 15 now. So take a look at this answer. Highlight at the same time. So your classmate did well, should not repeat. What is meant by the first book and the second book? At the same time 喎，邊有 first 同 second 㗎？好似頭先嗰句啦，總之 at the same time，你咪當將嗰兩本書搭起咗 ，first 就係高啲個本 ，second 就係低啲個本咯。So first book, second book is actually an acceptable and valid description to describe the whole situation, to give you the probability of 2 English books, 6 out of 20. 20. So that's 3 out of 10. OK 啊，好，咁開始識分咯，即係 without replacement 同 at the same time 嘅結果係一樣嘅。就算有啲事好複雜，即係你抽好多個波咧，但係 at the same time 嘅結果就同你 with replacement 一樣，你抽走咗佢再擺翻佢，其實就等於咁樣。So there are more fun exercises towards the back. First of all, this one. Lucky draw question. Sometimes why we want to learn this is we want to know the strategy. The strategy in order to get some items. It's not gambling like this one. It's a lucky draw. So which one is more likely to get the result you want? Do you want a DDD annual pass or a free air ticket to Japan? So if you want a free air ticket to Japan, would you do it with replacement or without replacement? There are some game stores, fun fair 都係㗎。你俾1張飛就有5個波，俾3張飛就有7個波。咁你應該俾幾多張飛咧？梗係3張啦，排得咁辛苦，係咪？玩耐啲咁樣樣嘢。即係 你哋有好多時即係都要做呢啲決定嘅，即係譬如就當射籃要射入4球，跟住如果一張飛就有5個波，3張飛就有7個波，甚至調翻轉你係要 set 呢個遊戲嘅規矩，你一張飛俾5個波佢，公平起見你3張飛俾幾個波佢咧？就一定唔係15個嘅，因為15個入嘅機會高好多嘅。如果你都係同樣要入4球嘅話，so these are actually calculations。即係若果分 fair 你做到好 precise 嘅話，你可以將每個 game 都諗下你啲 game rule make sense 嘅。不過呢個係純數學，仲有好多嘢要考慮嘅。都陣間可以考下你哋嘅，即係點樣去處理除咗數學之外有咩考慮？但係數學本身有乜嘢考慮咧？嗱，如果你話真係難啲嘅題目咧，你可以諗嘅let's say 你哋射籃中嘅機會有幾多啊？60%，呢度啲人好勁噶嘛。OK，60% success rate。So, 5 balls need 4 success. What's the probability? Okay. I'm just talking about 因為本來諗住射波，不過啱嘅，即係可能算啦。我係專做啲抽中嘅波嘅機會啦。咁所以就點啊？There are 2 red balls and let's say 3 green balls. What's the probability of 2 reds in 3 draws？ 咁有時你哋呢啲分 fair 真係會有啲咁嘅遊戲噶嘛？你個入邊有好多波你要抽咁樣。So how to calculate this? And in this question, there are many other variations that are allowed. For example, I can pump up the number of balls. Actually, you still need to ask me the question that Charmaine asked, with replacement or without replacement. So these are the things we do consider when we set up different games, especially if you, on the long run, you want to gain from that game, then you need to know the exact probability you can win or lose. We'll see this later. Back to the Disney annual pass and free air tickets to Japan first. She asked whether a tree diagram or table required. So my answer is you must list all outcomes systematically. So these are the 2 best ways we have to list all outcomes. If you miss just one outcome, I can disqualify you from the whole question without a table or a tree diagram. Okay, so that's why we prefer to have a table or a tree diagram. But if you already listed all outcomes, I mean, there are 16 outcomes. If you list all of them, I can't really say you are wrong. Alternatively, Form 5 method, but no step mark if wrong answer. Because that's not a proper method learned in Form 3, it's sort of considered beyond the syllabus. So if you give me a right answer, again, if I didn't specify you need to draw a table, then fair enough, you know a better method. But I need steps, okay? Steps are required, and Form 5 method is an acceptable step. For example, if I have time later on, I may actually tell you how I come up with these steps, but let's say 2 golden balls. If you know Form 5 methods, you may be able to write probability of 2 goals with replacement is this one, whereas probability of 2 goals without replacement is this one. If you don't know what I mean, then, well, if I have the time, I can teach you this, but don't use these methods yet. OK， 即係呢兩個咧並唔係你而家應該做到嘅嘢嚟嘅，不過呢個係話俾你聽，我接受呢啲答案，因為咁你 Form 5師姐都可以用呢啲答案㗎嘛，咁樣。OK。Anyway， 計完未啊 ？OK， here are the upcoming homework due on Tuesday. Just draw 5 tree diagrams or table. And as I told you, tree diagrams or tables are required when you consider such cases. 除非你識 Form 5個方法，咁所以用畫啦。唔係，同埋題目有要求畫㗎，有幾題。Listing all outcomes， 即係你就咁寫1、2、3、4咁樣。prefer 你話啦，唔係，我記得啦。Because I want to check your work, so draw at least 1 tree diagram and 1 table, no matter what method you use.